here. So this is our topic. It's identifying and graphing arithmetic sequences. This goes with lesson 4.1 in our textbook. The essential question is, what is a sequence? And how are sequences and functions related? All right, so we've learned about functions before, and now today we're going to learn about what an arithmetic sequence is. Your learning goal today is I can identify a rule for an arithmetic sequence that models a situation. Okay, and then here's some vocabulary for us. So our vocabulary here, we have sequence, which is a list of numbers or objects in a special order. All right, and then there's a picture right here to show you, an example of what that is. So a sequence, for example, might be 3, 5, 7, 9. And then we have this ... which means that it's going on forever. So it goes on till infinity. And then an arithmetic sequence is where the difference between one term and the next is a constant. Okay, a constant's just a number. In other words, we just add some value each time, forever, onto infinity. So you can see here, as we go from 3 to 5 to 7 to 9, what are we adding? What constant are we adding each time in this sequence? You could type it in the chat. Yes, 2. You guys are right, 2. We're adding 2 each time, okay? And so another vocab term is if we talk about, I think it was just a typo, Mauricio. If we talk about term of a sequence, then an element or a number in the sequence, okay? So you can see here in green, we're pointing to the first term is 3, the second term is 5, the third term is 7, the fourth term is 9, okay? Term, element, member, they mean the same thing when we talk about the sequence. Okay, and this is an arithmetic sequence because we're adding the same number each time. All right, and so when we talk about sequences, they're like a set. The difference is that in a sequence, the terms are in order. Okay, they have to be in a special order. And with a set, it doesn't necessarily matter. A sequence is like a set, except the same value can appear many times. If you have a set of numbers, then you don't repeat values. So an example here, we have 0, 1, 0, 1, 0, 1. This is a sequence of alternating zeros and ones. Whereas if I was trying to represent all these numbers as a set, I would just write 0, 1. I wouldn't repeat any values because this is just repeating forever. Okay, so when we talk about the notation for a sequence, we're using the same notation as we would with a set of numbers, okay? You list each element separated by a comma, okay? So 3, comma, 5, comma, 7, comma, and then if you keep the pattern going, this is where you put this ... And on the outside, we have these curly brackets, okay? And so we could call these curly brackets set brackets or braces. And these are actually on your keyboard, okay? So if you use them in your typing, they're on my keyboard. They're next to the letter P. All right, so this is our first interactive slide. And so we're going to complete the table and state the domain and range for the sequence. The first one is done for you. So here for number 1, we have a table, okay, and we have the letter N, and then we have f of n. So this should look familiar. This is like function notation, f of n. When we talk about function notation, we might have f of x, and then up here we would have x. Okay, so this is very similar to function notation. So, but we have n as our number and f of n. And the numbers for n, we're starting with 1, 2, 3, 4, 5. And then we're going to take f of n, which means we take n and do something to it each time. So it looks like I added 2 to n here. And then to get to the next one, or here, f of n. Oh, so maybe I'm not adding 2. Let's see. So 2 and then 6. So it looks like I'm adding 3. All right, so I'm initially starting with a value where n is 1, so it's just 3. And then 6, 9, 12, 15. We're adding 3 each time. All right, up here, this is just going in natural number order. So the domain are the numbers 1, 2, 3, 4, 5, but then it cuts off. It doesn't go forever. And our range is the outputs. So this is very much like a function. It is a function, in fact. Okay, so you have your inputs, which is the domain, and you have your outputs, which is the range. And so there is the pattern of adding 3 each time. I guess we could also think of it as maybe the function for what we have here. Maybe it's f of n is equal to 3n, right? So if n is 1, 3 times 1 is 3. If n is 2, 3 times 2 is 6. So that would be the function for this, but this is the domain and the range. You guys are going to do 2. All right, so number 2 is here. Again, you have a table with a row of your n values. And so these are our numbers. They're following a pattern of starting with 1, 2, what goes here, 4, what goes here. You got to fill in these 2 boxes. And then whatever the function is, f of n, well, the output is first 10, then a mystery number, then 30, then a mystery number, then 50. So you're going to fill in these 4 boxes, and then you're going to type out what the domain values and the range values are. Makes you feel so strange. Okay, now remember, guys, as we go through any Pear Deck lesson or anything where I'm asking you to do something in class, you definitely need to participate. Okay, and so there's some things that concern me. If I look at how many people are in the meet, there's 26. 2 of those are me, because one is myself and one is me presenting. So there's 24 students that are in this meet that should be hearing me tell you that you need to be in the Pear Deck. Our Pear Deck is up to 20. So there are 4 students that are listening to the meet that have not joined the Pear Deck. You are absolutely required to join the Pear Deck if you want to get credit or attendance in class. And of the responses, we have 12 of you, thank you, that have started this. This is fantastic. There are still 8 more of you that are logged into the Pear Deck but have not started this slide yet. So as you go through these, remember, you have to participate. If you do not participate, then in Aries, they gave teachers these codes. Okay, so right here, non-responsive. If at the end of class, I go through and look at the Pear Deck and you haven't responded, okay, that's non-responsive. You are not, you're here, but you're not technically really participating. No one seems to be engaged in other websites that I can tell at this point in time, because I can see your screens. Everyone seems to be, if you're in the meet, you're either in the meet or you're on the Pear Deck. So make sure you have those things open. Go back here, we're up to 14 out of 21 responses, so that's good. Mentioning that, I got one more person to join. So make sure you have the Pear Deck tab open. If you're using multiple devices, that's fine. If I'm looking at your screen and I don't see that you have Pear Deck open, then I'm going to mention that to you. You know, it may be that there's a handful of us that have joined the meet and then went back to bed. And that's not giving you your attendance credit, okay? Your teacher's going to find out that you're not paying attention. So even though it shows as present, you didn't respond to the teacher. That's not a good thing. If you have an issue where you're not able to load Pear Deck, there's something happening with your internet or something like that, you know, there's excusable reasons for not doing this, but communication is the key there. So if you are having an issue with something, that would mean you need to communicate with me about that. You can write me a message on GoGuardian privately. There's another person that needs to open Pear Deck. All right, so we got 15 out of 22 responses. We got 2 more people to join that hadn't joined yet. There's still 2 people that have not joined Pear Deck. And there's the 7 of you that haven't responded plus the 2 that haven't even joined. Okay, so the 9 of you at this point right now, you are not being responsive. That's not good. So let's look at what those of you that responded wrote. This example right here. Perfect. Okay, that is in fact the pattern. Okay, these numbers are increasing. They're integers. Okay, so when we deal with sequences, these values in this row for n, you know, it doesn't necessarily have to be the letter n, but your inputs for a sequence are integers. Okay, you're not going to have any decimals or fractions with sequences. And then your outputs, something is happening. This is like a function as well. It's following the same pattern here. So this is a sequence where we're adding 10 each time. Let's see. This person got it as well. Nice job. Nice job. Perfect. So you definitely have to pay attention and participate. And so when I see that you guys are doing this and you're getting the correct answers, then it's like, I feel like, yay, you're understanding. If you don't participate and you just open up the meet and you zone out, you go like play on your phone or you take a nap, you're not going to learn this stuff and you're going to struggle. Okay, it's the beginning of the semester. Let's start it out strong. Okay, so we're doing really good here. Now, if you wanted to notice which one is yours when it pops up, you can always use like a different color. And you'd be like, oh, there's my work. Or put a random dot here. That would also work. Okay. So you can use the writing tool to draw in the answers. And you can change the size of the pen that you're using. Okay. Yes, Mauricio, I did recognize your red one. Okay, so if you wanted to, instead of type and draw, you can change the size of the pen so it's not so big and it's a little bit easier for you. All right, awesome. So 23 people have joined. You're in it, okay? You will have a chance to get caught up, but not right this second because we're moving forward. Okay, here we go. We are on slide 6. So part of the essential question today, I come back here, says, what is a sequence and how are sequences and functions related? Okay, we kind of just saw how a sequence and a function are similar, right? And we're going to continue working with that. So I'm right here. So graph the sequence that represents the situation on a coordinate plane. So Rebecca had $100 in her savings account in the first week. She adds, Okay, if you're adding something, $45 each week, the same thing each time, this is an arithmetic sequence, okay? When you add the same amount each time, that's an arithmetic sequence. She adds $45 each week for 5 weeks. All right, and then the savings account balance can be shown by a sequence. Yes, and so we have this graph here. We're going to graph the sequence that represents this situation here. And so along the x-axis, we have weeks, and the y-axis, we have savings. So the amount of money that she is saving is the y-axis, and then the time, weeks, is the x-axis. Anytime you are trying to graph two things where one of them is some measurement of time, time will always be on your x-axis. And so weeks is a measurement of time. That's the independent variable. And so this is all restricted within the first quadrant, all right? We're starting at 0. Our time starts at 0, and we're moving forward this way. And so after 1 week, okay, well, actually at 0 weeks, where does she start at 0 weeks? She had 100 in her savings account in the first week. So when she starts, aha. So week 1, we're at 100. Then, so that's our first week, week 1, we're at $100. And she's adding $45 each week. So at week 2, 100 plus 45 is 145. And then at week 3, we add another $45. So we're up here at 190. And then week 4, we add another $45. Week 5, we have another $45. So not only is this a function, it's taking on the pattern of a straight line. This is also what we call a linear function. Okay, so this sequence, this arithmetic sequence, is also a linear function. Now we're not going to connect the dots. We're going to leave them just like that. It's tempting to put a line through dots, okay, but this is something that's happening every week, okay? There's not something that's happening in between the dots, okay? So your function is just these dots here. This is our graph sequence. You're going to do one of these now. So slide 8, we're going to graph the sequence that represents the situation on the coordinate plane. Adam has $300 to donate. For the next 5 weeks, he donates $60 each week to a different charity. Wow, Adam's nice, huh? His remaining donation money can be shown by a sequence. So it's asking us to represent his remaining donation money. You want to be careful that you're not trying to graph what he's donating, because that's not what it says to do. It's, you want to graph his remaining donation money. So we're starting with, Adam's starting with $300. And so on our coordinate plane here, we have the donation amount on our y-axis, and we have the time, weeks, on the x-axis. Okay, so something is happening each week. Okay, so again, we're only going to have points on this graph. We're not going to be drawing a line. Okay, it's going to be points. And this is going to represent the sequence. So our first point, where would our first point be? So I have a couple of you who have already started. Let's see if we can figure out where our first point would be. Oh, wow. Oh, that's nice. So there's some confusion here, and so let's think about this real quick. Do we start at 0? Do we start at $300, or do we start at 1 with $300? Should the first point be here, or should the first point be here? Should be here. Or should be all the way over at 300. It's confusing, right? Adam has $300 to donate. Okay, so he has $300 to donate. And then for the next 5 weeks, he donates $60 each week. So because it's saying for the next 5 weeks, that implies to me that at week 1, we are starting at $300. So I think your first point would be here. Week 1 is at $300. Yeah, I think it would be at week 1. Okay, and now for the next 5 weeks, week 2, 3, 4, 5, and 6, he's going to donate $60 each time. So he's consistently donating the same amount. So for week 2, how much money will be remaining of his $300? $240. That's right. 300 take away 60 is 240. So for week 2, here 250 would be here. So 240 is going to be slightly lower, just like that. All right. So if I come back over here and look at what you guys are doing, this one's pretty close. It looks almost right on. You want to change that one. This one looks really good. We're getting there. This one we're going to have to shift it over a little bit. So don't connect it with the line. And the reason is that in between the times, you know, he's not donating money at like a consistent rate. It's not like it's 12 o'clock, here's $1. And then it's 1 o'clock, here's $1. It's 2 o'clock, here's $1. You know, he's waiting and like he's doing $60 on the week. So we're not going to have a line connecting the dots. This looks good. We're getting there. Perfect. Good. Great. Yes, so this is what we want here. Now, your very last point, though, so this is very close. But on week 6, let's see what happens. So for week 3, if we had 240 before, what's 240 take away 60? $180. 180 take away 60. Thanks, Mauricio. I don't have to think so much. 120. Okay, and then on week 5, he's left with $60. On week 6, he's left with $0. So your last point needs to be all the way down at 0. Okay, he doesn't have any money left at week 6. He's donated all of his money. And that's it. So you want to make sure that your points, the last point here, we are on the axis. All right, so you may want to adjust your points just a little bit. Like this one's great. This one, a little bit, you have an extra week here. So this point should be here. This one is, we need to shift it over a little bit. That works. Happy face. This is probably Mauricio. No, maybe. Here, we're getting closer. Okay, so good. So this one, and these should take on the form of a straight line. Okay, I know it's a little hard, and we're doing the best we can with our mouse and trying to do this stuff. Okay, this looks good. This one would be a little bit higher. All right, so I got 15 of you to try this one, which is great. I'm almost ready to put you in student pace mode. So if you didn't quite get to everything you wanted to do, I will do that. I want to show you, though, the next slide here. Okay, so a couple more slides, and then I'll put you in student pace mode. Okay, so if you didn't quite finish something, you can go back. But when we talk about sequences and the rules that define them, there's 2 types. So we have an explicit rule and we have a recursive rule. Okay, so explicit rule is a sequence where the nth term of a function of n of any whole number n greater than 0. Okay, you can find any term in the sequence that you want. You can find the 5th term, you can find the 100th term, you can find the 1st term. You don't have to rely on the previous term to find it. Okay, so an example of that is here. So this function of this sequence, f of n is equal to n squared plus 2. Whatever value of n I want, whichever term, I want the 10th term. I could just put a 10 where the n is, okay? 10 squared is 100. 100 plus 2 is 102. I could figure out any term in the sequence without having to know other information. That's an explicit rule. The other type of rule is recursive. Okay, now recursive rule for a sequence defines the nth term by relating it to one or more previous terms. So this one is not, you know, exclusively just itself. It relies on other calculations. And so an example of a recursive rule is here. So maybe if my function, I'm just kind of looking here at this part, f of n. Okay, this is the general form. F of n is equal to f of n minus 1 plus 10. So in order to figure out the nth term, if n is 10, and I come over here, well, I know that this is still 10, that doesn't change, but I have to know what n minus 1, I have to know the f of 9th term, okay? And to get the f of 9th term, I have to know the f of 8th term. I have to go all the way back and forth until I get to f of 1, which is defined. That one's given to you, it's 4. So the f of 2 term is f of 2 minus 1, or f of 1 plus 10. Okay, so what it's showing you here, and this will make a little more sense when you see an example more worked out. But at this point right now, just know a recursive rule, it relies on knowing one or more previous terms. Okay, so you have to know one or more previous terms. Where an explicit rule, you could figure it out without having to know any other terms. So this one's a little bit easier. Explicit rules are easier than recursive rules. All right, the last slide of this is a video that you can watch. I'm going to put this on student pace mode. Okay. I'm going to stop this recording.